started with designing a rapid sand filter, monomedium, meaning one type of media, just the sand. And we calculated the number of filters needed by two methods. One is based on flow rate. If it's less than 8,000 meter cube per day, you need 2 filters. Greater than 8,000 meter cube per day, you need minimum of 4 filters. And then we had the formula, and based on the formula, we calculated 2.65, and you have to pick the bigger one. So you pick the 4 filters. And then we need to calculate the surface area. I gave the formula in the previous video for surface area. And these are some of the design conditions. You need a filter bed area of 25 to 100 meters square. A filter has 2 components, a filter box and a filter bed, which is placed inside the box. Filter bed is where actual filtration happens. So the sand will be in filter bed. The box will house the filter bed. Now we have to calculate the dimensions. In other words, length, width, and depth of the filter. So one data part of the question, the overflow rate, which is Q, is given by loading rate. I gave that formula Q, loading rate, or filtration rate, so this value is equal to 216 meter cube per day per meter square. So with these numbers, we are going to calculate the surface area, which is A equal to flow rate 18,400 divided by number of filters 4 times Q, this value 216. This comes out to be 21.96 meter square for each filter. So each filter will have this much area. So you'll have 1, 2, 3, 4. 4 filters. Each filter will have 21.96, 21.96, 21.96 meter square. Okay? Now, you have to operate the filters 24 hours. At some point, you have to take one off for maintenance. Let's say this is taken off for maintenance. Okay? So maintenance meaning when you filter it, whatever particles that is present in water is retained in the filter, clean water flows through. You can use the filter only for so long. At some point you have to stop it because you're not removing as much particles as the design requires. So at that point you take it off, you do something called backwashing. We'll talk about that in a minute or later. When you backwash, you remove most of the particles in the filter bed, and the clean filter bed comes back into operation. So when you take this off for maintenance, you have only 3 filter beds. And these 3 filter beds have to take the excess load coming or filter the excess water because 4 is not available. So to accommodate one filter for maintenance, increase area of each filter by 1/3. So now area equal to 21.96 plus 1 by 3 times 21.96, and that number is 28.4 meters square. So now all the 4 filters will have 28.4. So what this means is you are providing little extra, 1/3 extra capacity in each filter. Thereby, when one filter is taken off for maintenance, filters 1, 2, 3 can handle the flow rate of 18,400 meter cube per day. That's why you increase the area of each filter by 1/3, so that you have 3 always in operation. The 4th one is in maintenance. So when one goes for maintenance, you'll have 2, 3, 4 in operation. That can handle the entire flow rate. That is the idea. So now we know the area. So area equal to 28.4 meters square for each filter. Now we need to calculate the length and depth. So design criteria to calculate length and depth. Length L divided by width W is 2.1 by 1. This is recommended. Now range, so this is W, L by W, the range is 2 to 1 to 4 to 1. This is the allowable range. We are going to use the recommended range of 2.1 to 1. So I'm going to delete this. So use a recommended range. So L by W equal to 2.1 by 1. So L equal to 2.1 times W. So area A equal to L times W, that is equal to 2.1 times W, that is 2.1 W square. Okay? So now 2.1 W square is equal to 28.4. So W will be equal to 3.67 meters. Length equal to 2.1 times W. That will be 2.1 times 3.67 equal to 7.72 meters. So this is a filter. Now each filter is built as two cells. So this is cell number 1, cell number 2. Now this is length L equal to 7.72 meters, width equal to 3.67 by 2, width equal to 3.67 by 2. So what we designed is length and width for one filter. We have 4 filters in the system. We designed the length and width for one filter, and each filter is built as 2 cells. So cell 1, 2, and each cell will have half the width. So the whole thing is one filter. Each cell is half the width. Now this part right here is about 0.6 meters, and it is called a gullet. So each cell is separated by a distance of 0.6 meters, and that spacing is called gullet. It involves a complete design. We are not going to do the design for this class, but I want you to know that each cell is separated by an opening called gullet, and it is about 0.6 meters in width. So we have the length, width. Now we need to find the depth. So we have the length times width equal to 28.4, which is 7.72 times 3.67. We need to find depth. So the design criteria: media depth D divided by effective size E. So media depth meaning the depth of particles or depth of sand or any material that forms the filter. The effective size is the pore space in between those. Or the size of, the effective size is going to be the size of the media. Now the ratio, depth to E ratio is 1000, 1250, 1500 to 2000. Now 1000 refers to application. So 1000 corresponds to mono sand or dual media beds. So the depth to effective size ratio in mono sand or dual media beds is about 1000. Now in tri-media, generally coal, sand, garnet, the depth to effective size ratio is 1250. Now very coarse monomedia is 1500 to 2000. Since it's a monomedia, the effective size E is 1.5 to 2 millimeters. Okay, this is the design, or these are the design criteria for calculating the depth of filters. Now we are going to use monomedium, rapid sand monomedium. So this is the one we are going to use, 1500 to 2000. Now let's assume the midpoint, D by E equal to 1750. allowable range is 1500 to 2000. We are assuming depth to effective size ratio of 1750, and E is given 1.5 to 2. So assume E equal to 1.5. I'm assuming on the lowest possible one. So depth equal to 1750 by 1.5. So D equal to 1750 into 1.5. So depth equal to 2625 millimeters or 2.625 meters. So now depth D is 2.625 meters. So we design the length, width and depth of the filter, and we did that by calculating the number of filters needed, the surface area needed, and then making an assumption that depth to effective size is 1750 and effective size is 1.5. So this completes our design of a granular filter. Now we are going to look one more slide that will show us the operation of a granular filter. Well, I'm going to stop at this point, take a break, and then come back to that.